I was looking at the stack of research we have on the table today, and I keep coming back to one specific date.
Oh, 2026.
Yeah, exactly. 2026.
Right.
Because if you work in software testing right now, or, even if you're just adjacent to it in DevOps, 2026 isn't just next year on the calendar.
No, it's definitely not.
Looking at these industry reports, it honestly feels like an extinction event for the old way of doing things.
It's a harsh way to put it,
Yeah.
but the data really backs you up there. The era of the bug hunter.
Right, the person just clicking around.
Exactly.
Yeah.
The person whose entire job description is just manually clicking through an app to see if it breaks. That era is effectively over. We are seeing a complete paradigm shift.
And that is the core tension we are unpacking in this deep dive today. We aren't just talking about a simple title change on your LinkedIn profile.
No, not at all.
We're talking about a survival strategy. We are looking at the evolution from manual quality assurance classic QA to the SDET.
Software development engineer in test.
Right. And based on everything we've read, this is literally the difference between being a bottleneck in the system and being a strategic architect.
That word architect, that is key. The fundamental shift here is moving from checking quality to architecting quality. And the driver for all of this really is pure speed.
Speed. The velocity of modern deployment. I mean, we're seeing companies deploying code hundreds of times a day via CI/CD pipelines.
Yeah, and a human being manually checking a login screen simply cannot physically click fast enough to keep up with that volume of code commits. It's impossible.
Right. If you are relying on manual regression testing in a modern DevOps environment, you are the anchor slowing the ship down.
You just can't keep up. So the industry is demanding a role that bridges that gap between dev and ops.
So for you listening today, maybe you're a manual tester feeling the heat and looking to level up, or maybe you're a developer curious about where the high-value jobs are heading. Our mission is to map out that exact transition.
Give them the roadmap.
Exactly.
Yeah.
We're going to walk through the day-to-day reality of this role, the specific technical skills you need beyond just, learning to code, and, of course, the elephant in the room,
AI.
AI, which is huge.
It is. The 2026 landscape is wild. AI is rewriting the rules on everything, from the tools we use to the actual salaries these roles command.
So let's dive right in. First things first, let's define this identity shift. We hear SDET thrown around a lot as a buzzword.
Way too often.
Yeah. But looking at the job descriptions and the technical breakdown, it's a fundamentally different discipline than traditional QA.
It really is. Traditional QA is often what we call black box testing.
Meaning you can't see inside.
Right. You are approaching the software strictly like a normal user would. You don't know, and frankly, you often don't care how the sausage is made inside the code.
You just want to know if it tastes right.
Exactly. You click buttons, you enter data, you see if it explodes.
It's reactive. You wait for the build, you try to break it, you file a ticket.
Precisely. But an SDET is, by definition, a developer. The DE literally stands for development engineer. They have white box visibility.
So they are looking at the actual code structure.
The structure, the API calls, the database queries. They don't just find bugs, they write software that finds bugs.
I really like the phrasing from one of the technical papers in our stack. They called it building the robot that does the clicking.
Building the robot.
Yep.
That's it perfectly. But it's more than just automation scripts. If we look at the day-in-the-life data we have, it totally shatters the myth that this is a solitary coding job where you're just locked in a basement.
Oh, I noticed that too. The schedule is surprisingly social. Like the morning block, roughly 8:00 to 10:30 a.m., isn't heads down coding. It's stand-ups and requirement reviews.
And that context is critical. In the old world, QA waited until the feature was built to figure out how to test it.
Yeah, at the very end.
Right. But the SDET is there when the feature is being designed. They're sitting in the meeting asking, how are we going to test this? And they're asking that before a single line of feature code is actually written.
This connects to that concept of shift-left testing, doesn't it?
Yes, precisely. Imagine a timeline of software development going from left to right. Design is on the left, deployment is on the far right.
Okay, I'm picturing it.
Traditionally, testing happened way over on the right, just before release. Shift left means dragging that testing process way over to the design phase.
Because if you catch a logic error or a requirement gap in the design phase, it costs pennies to fix.
Exactly.
But if you catch it in production, when users are already complaining,
It costs thousands, sometimes millions, depending on the bug. So the SDET is essentially a financial risk mitigator. They are designing the test plan while the developers are designing the feature.
Okay, so after those morning meetings, we hit the core work block. Late morning, like 10:30 a.m. to lunch. The research highlights this as the heavy lifting phase.
Yes. This is where the actual engineering
This
happens.
is where you're in your IDE, your integrated development environment.
Yep. Writing scripts in Java or Python. You're using tools like Selenium for web apps, Appium for mobile, or Postman for APIs. But here's the key distinction.
What's that?
You aren't just scripting click button A. You are building an entire framework.
And that distinction is vital. It actually brings us to one of the most vivid anecdotes in the research materials. We have to talk about the Notepad++ nightmare.
Oh, man. Every senior SDET shudders when they hear this story.
It's a classic horror story.
It really is. It's the perfect example of what happens when you automate without architecture.
So for the uninitiated, let's paint the picture. The story goes that there was a tester who was incredibly eager, really wanted to prove himself.
Right.
He learned to script, and he wrote hundreds of automated tests for a website. And in every single test, he explicitly told the script, find the button with the HTML ID, submit 123, and click it.
Which seems totally logical on the surface. Find the button, click the button.
Until the developers decided to refactor the code, and they changed that button ID to submit 40056.
And suddenly, 500 automated tests fail simultaneously.
Bam. Red across the board. And this core tester had to open Notepad++, do a massive find and replace across dozens or hundreds of individual files.
And just pray he didn't accidentally break anything else while doing it.
Exactly. That is the definition of brittle automation.
It works until it doesn't, and then it's an absolute disaster to fix. It turns you from someone who is engineering quality into a firefighter who is just frantically patching leaks all day.
So to avoid that exact Notepad++ nightmare, the research points to design patterns, and specifically the page object pattern. I want to double click on this because it seems to be the dividing line between a novice scripter and a pro SDET.
It is arguably the single most important concept for maintainability. Think of the page object pattern as a decoupling strategy.
Decoupling the test from the UI.
Exactly. You create a separate file, a page object, that serves as a map for that login screen.
So the map holds all the ID details.
Right. The map says, hey, the submit button is located at submit 123. Your 500 tests just say, go to the map, find whatever the submit button is, and click it.
They don't know the ID themselves.
No, they just know the map.
So when the developer eventually changes the ID to submit 456.
You update the map once, just that one single file, and all 500 tests automatically work again. You've turned a 3-day disaster into a 30-second fix.
That makes so much sense. It separates the test logic from the page details.
Exactly. It makes your tests robust. It allows the application to evolve without breaking the testing suite every single day.
And as we look at modern systems, that stability is incredibly hard to come by because we aren't just building monolithic apps anymore. We're dealing with microservices. That was another big technical hurdle mentioned in the roadmap.
Oh, yeah. That throws a massive wrench into how we test things.
Because it's not just one big app anymore.
Right. It's dozens of independent services, maybe a payment service, a user service, a shipping service, and they are all talking to each other via APIs.
So how does an SDET even handle that? You can't just spin up the whole universe on your laptop every time you want to test one tiny thing.
No, you'd run out of memory instantly. That's where contract testing comes in.
Contract testing.
Yeah. It's verifying that different services agree on exactly how to talk to each other. Think of it like a strict legal contract.
Okay.
The payment service says, I promise that if you send me a valid user ID, I will return a valid credit card number.
And the SDET writes a test that strictly enforces that promise.
Exactly. You verify the contract is honored. It prevents integration disasters where service A sends data that service B doesn't understand.
Which would break the whole checkout flow.
Right. It's a very specific, high-value skill for an SDET because it allows you to test fast and in isolation without needing the entire system running.
Okay, so we've established the baseline here. You need to code. Java and Python are the heavyweights, and you need to understand architecture like page objects and APIs. But the outline we're looking at pivots hard right here to the 2026 landscape. And frankly, this is where things get a little scary for people.
The AI disruption.
Yeah. There is a palpable fear in the industry right now. Like, if AI can write code, do we even need SDETs?
It's a common fear. But the projection data we have suggests the exact opposite. The role isn't disappearing at all, it is mutating.
Mutating how?
It's shifting from being a writer to being an overseer.
Overseer. That sounds powerful, but also a bit ominous. Unpack that for us.
Well, think about all the grunt work we just described. Writing boilerplate code, the standard setup code you have to write for every single test.
Like open the browser, go to this URL,
Yeah.
wait for the page to load.
Exactly. Tools like GitHub Copilot allow SDETs to generate that boilerplate just by typing a natural language prompt.
So you just type, write a test case for invalid login.
Yep. And the AI spits out the foundational code instantly.
Wait, so the SDET isn't typing the syntax anymore?
They are, but they're editing and refining rather than writing entirely from scratch.
Ah, I see.
It shifts the human focus to the edge cases, the complex logic, and the overall strategy. You aren't wasting time on the easy stuff anymore. You become the architect deciding what to test, while the AI handles the how.
And what about maintaining tests? We talked about the brittle tests earlier. The Notepad Nightmare AI seems to be the cure for that, too.
Oh, absolutely. This is one of the coolest advancements out there right now. Self-healing scripts.
Self-healing! It literally sounds like science fiction.
It basically is. There are AI-driven tools, the sources mentioned, platforms like Testum or Functionize, that use machine learning to literally watch the application.
Watch a how.
Well, if a UI element moves, or if its ID changes, the tool analyzes the other attributes of that element.
Like its color or the text inside it.
Exactly. It sees, okay, the ID changed, but this is still a blue button. It still says submit, and it's in roughly the same spot on the screen. I'm 99% sure this is the exact same element.
So the test doesn't fail.
The test doesn't fail. The AI heals the script automatically in the background. It totally prevents that false positive where the test fails just because a button moved 2 pixels to the left.
Wow, that frees up so much time.
It really does. And then there's mobile testing. We have a source here discussing a tool called Quash.
Right, Quash.
This is fascinating because it bridges the gap between design and verification instantly.
How does it do that?
It can generate test cases directly from a design file or a UI mockup.
From a picture.
Yeah. You feed it the picture of what the app should look like, and it creates the tests sometimes before the developers have even finished writing the actual code.
Okay, that is shift left taken to the extreme.
It is. It creates what they call unbreakable tests that adapt as the app evolves.
So let me get this straight. The SDET in 2026 isn't just writing scripts.
Correct.
They are managing a team of AI agents.
Essentially, yes.
I've got one agent healing my scripts, another generating test cases from Figma designs, and I'm sitting in the middle conducting the orchestra.
That's the overseer role. You are verifying that the AI is testing the right things. You're interpreting the results. You're even using AI for visual testing.
What's that?
Spotting if a button is the wrong shade of blue, which a traditional script would never, ever notice. You are the strategist, ensuring all these AI agents were actually doing their job correctly.
This all sounds incredibly advanced, and usually advanced skills mean better pay. Let's talk about the payoff here. What does the financial picture look like for an SDET in 2026?
The numbers are incredibly compelling. Because the demand for automation skills is so high right now, and because AI is acting as a massive multiplier for what one single person can do, salaries are surging.
We have some data here comparing 2025 to 2026 projections, right?
Right. We're seeing senior SDET salaries projected to rise significantly. We're looking at moving from around that under 55K mark to upwards of 180K.
180K, that is a serious jump.
And if you specialize, if you become an AML test engineer, someone who specifically tests the AI models themselves, you can command salaries up to 200K or more.
At $200,000, that really puts the checking versus architecting distinction into perspective.
It really does. And beyond just the salary, it's about job security. The manual tester is vulnerable.
Because if a tool can click buttons faster than you, you're at risk.
Exactly. But the SDET is a strategic asset. Companies are desperately upskilling their teams because manual testing simply cannot keep up with the speed of the market.
Right.
If you are the person who enables the company to release software 10 times a day without breaking anything in production, you are indispensable.
So if you're listening to this and you're motivated, you want that 180K, you want to be that overseer, what is the immediate next step?
Yeah.
Because it feels like a really steep mountain to climb for manual QA.
It is a learning curve, for sure.
Right.
But you have to start with the coding foundations we talked about. Java or Python. Do not skip that step.
And the advice from the experts in our research isn't just go read a textbook. It was specifically to fail faster.
Yes. That is the best mindset you can possibly have. Don't get stuck in tutorial hell where you're just passively watching YouTube videos.
Right.
Pick a website, literally any website, and try to build a project. Try to automate a simple login page.
And expect it to fail.
You should hope that it fails, because when it breaks, You have to debug it. You have to read the error log. You have to Google the exception code.
Figure out why the element wasn't found.
Exactly. That specific struggle is where the actual learning happens. You learn more from one failed script that you have to fix yourself than from 10 hours of reading about syntax.
That's great advice. Start with the code, fail fast, and then move to the frameworks.
Right. Master the page object pattern so you don't drive yourself crazy with maintenance down the road.
Mm.
And then once you have those basics locked in, embrace the AI tools.
Don't run from them.
No, don't be afraid of them at all. Learn how to use them to make yourself faster and more efficient.
It really is a journey. It starts with that very first line of code, pushing through the frustration, and then utilizing AI as your personal productivity multiplier.
Absolutely. It's about viewing yourself not as the person who catches mistakes, but as the person who builds the safety net that allows the whole company to move faster.
That is a great way to frame it. And actually, here's a final thought to leave you with, something to mull over that really stood out to me in the notes today. We talked a lot about AI generating tests and AI executing tests.
Right.
As AI begins to do more and more of that heavy lifting, writing the test, running the test, healing the test, the human role actually shifts to something a bit more philosophical. We have to define what quality actually means.
Oh, that is the paradox of quality.
What do you mean by that?
Well, an AI can ensure the code works functionally. It can ensure the button clicks and the data saves to the database. But who ensures the software is actually good for the user?
Right. Who ensures it feels right?
Exactly. Who ensures it actually solves the user's problem in a meaningful way?
That's the human element, the empathy.
Empathy. Yes. As we automate the functional verification, the SDET's role might evolve into being the ultimate guardian of the user experience. We aren't just shipping bug-free code anymore. We need to ship software that actually matters.
So you automate the checking so you can spend your human brain power on the actual value.
That's the future of the role right there.
That is a powerful place to end. The future isn't just about code, it's about value. Thank you for taking this deep dive with us today. If you've been hesitating to open that code editor, take this as your sign.
Start today.
Exactly. Start today, write that first script, break it, fix it, and we'll see you next time.